So you'll see here that the way this is named, okay, it says triangle MTA. You see that triangle MTA right there. It's congruent to triangle XAT, this triangle right here. Other answers here, Alex, we're talking about different triangles, and so you have to like kind of consider those different triangles. But this one, it not only names the triangles correctly, MTA, right? So M to T just matches up with the X to A, T to A, and T to A, and then MAXT. So they match up. The corresponding parts match up, and it is side angle side because you have a side right here, the angle congruent to this side and this angle, and they both share TA there. So it's side angle side. Side, angle, and then this side is shared. It's not marked congruent, but since it's shared, it's going to be congruent. All right, moving on here real quick. Number 2. Okay, number 2. Okay, so L is parallel to M, and the measure of angle 1 is 107. So I'm going to go ahead and mark that in here, 107 degrees. Okay? Which combination of postulates and theorems cannot, keyword there, cannot be used to find the measure of angle 7 down here? Oh, you can't quite see it. Let me scoot it up some. Okay, angle 7. So let's look. Which one of these cannot be used? So let's start with A. If lines are parallel, then corresponding angles are congruent and linear pairs are supplementary. So we're starting with angle 1 because that's what we're given. What's corresponding to angle 1? Angle 5. Okay, so we have angle 5 is going to be 107 degrees, and linear pairs are supplementary. Well, 5 is a linear pair with what other angle? 6 or 7, and since we want to find 7, can we use corresponding angles and then linear pairs to get 7? Yes, we can. So that one works, so we have to throw it out, okay? Because it works, we don't use it. We want to find which one cannot be used to find the measure of angle 7. Let's look at B. B says use vertical angles are congruent. So what's vertical, back to angle 1 here, what's vertical to angle 1? 4. So now we're at 4, we have 4, and if lines are parallel, then alternate interior angles are congruent. Well, what's alternate interior to 4? 5, right? It's alternate, so be careful. It's not 6, that'll be co-interior, same sign, 4 and 5. Uh-oh, did we get to angle 7? No, so it could be angle B, because answer B, because it didn't work. Let's look at C. C says linear pairs are supplementary. So let's see here. Linear pairs, that'd be like 1 and 2 are a linear pair. So again, we start back at angle 1. Linear pair, we would know angle 2. And then alternate exterior. Well, what's alternate exterior to angle 2?
8.
Not 8.
Or 7.
7. It would get us to 7. Again, 5's alternate, but it's on the interior. So it's 2 and then out to 7 here. So that would get us to 7, so it's not C. And then finally D, vertical angles are congruent. So we start back at angle 1. Vertical angle is 4. And if lines are parallel, corresponding angles are congruent. So 4 is corresponding to what? What angle?
3.
Not 3, nope. What does angle 4 correspond to down here? 8. It's in the same position as 8. And then linear pairs are supplementary. Well, 8 is a linear pair with 7, right? They make a straight line, and so that does get us to 7, so it can't be D. So B is the only one that does not work. A, C, and D do get us to angle 7, but B does not. Okay, questions on number 2? All right, number 3 then. Here we go. Triangle ABC has vertices. A, B, C. I'm not going to list those out. The figure was translated using this rule, x plus 2, y minus 3, and then rotated 90 degrees clockwise about the origin to create A prime prime, B prime prime, C prime prime. In the coordinate plane, where would A prime prime be located after the 2 transformations? So here's my question to you. Do I need to transform A, B, and C in this problem? No, because all I'm looking for here is A prime prime. So what's the only point I need to transform? A. So I'm going to start with A at negative 1, 2. Negative 1, 2. There's A. Okay, the first rule we're supposed to do is x plus 2, y minus 3. What kind of transformation is that?
Translation.
A translation, which direction?
We're going right 2, down 3.
No, well, the translation first. We'll do the rotation in a second. The translation is x plus 2, that means which direction?
Right.
Right 2, and then y minus 3 means we're going which direction? Down 3. So right 2 from A, 1, 2, and down 3. 1, 2, 3. There's where A prime is going to be. Okay? Now, some of you guys might be able to see, we're going to then rotate this 90 degrees clockwise. So 90 degrees clockwise means we're going this direction. Well, remember to rotate 90 degrees, we're going to draw the line from A prime to the origin, because we rotate about the origin. But I bet some of you guys can tell me right away, where's A prime going to rotate to if we rotate 90 degrees?
-1, -1.
Yeah, it's going to rotate 90 degrees this way, right over here to -1, -1. Okay, and so the answer there is A, -1, -1. That's where the coordinates for A prime prime will be. If you forgot how to do your rotations, let me show you real quick using the patty paper. Okay, remember you take your patty paper, you trace, okay, the origin, and you trace where the point is, and then you draw that line that connects them. Okay? And then you're going to measure 90 degrees from that line right there. So I'm going to put my protractor down and measure 90 degrees, which is right there. Draw my little line. Oop, that's not a very good line. Out to that little mark, and you can see I made a 90-degree angle, and I'm just going to take my point and rotate it about the origin. There it is, 90 degrees at -1, -1. So there's the answer A. Okay, that's how we do that.
So we don't rotate it. Oh, never mind.
Okay. All right, let's move on to number 4 then real quick here. Number 4, which of the following is not a step to bisecting an angle? What do we say here? It's C. Okay. Remember, this A is like that's your first step of bisecting an angle. You put your compass point on the vertex and you swipe to hit both sides. B is like the last step of bisecting an angle. So you already have the 2 swipes there and the crisscrosses and draw through it. And then letter D, that's like in like the second or third step of your bisecting an angle. You already have the 2 swipes, and then you swipe in from one of those points to the center. Okay, so these are all parts of bisecting an angle, but this one's not. You never use the straight edge to draw one side of the angle there. That's a different construction. Okay?